Alright, in this video we're going to take a closer look at functions and specifically their domains and range. So let's take a look. We had started talking about functions last week and if a set of relations is specifically a function. So let's review a little bit. A domain is your set of inputs for your relation and the range is the set of outputs. So when we take a look at this, our domain here is going to be your x values. Your range will be the y's. And then we're going to take a look and see if we can determine if it's a function or not. So remember your function, you're going to look here at the x column to see if you have any repeated x's. In this case, we do not have any repeated x's, so we can call this one a function. And your domain is the set of x values. So we start off with these curvy little braces and list our domain. 3, -1, -6, 1, and 4. And then for the range, we go ahead and list the y's in the same way with those little brackets. Let's take a look at this next one. This next one is just these 3 dots that are on our graph. So we want to look for the domain, so that would be all the x values. So this ordered pair, let's see, is 2, 4, 6. So this one is 6, 1. So 6 is going to be part of my domain. 1 will be part of the range. When we take a look at this, we can go ahead and list our ordered pairs. So this one is -1 up 2, 4, 5. This one over here is -2, -3. So when we take a look at it, we can see that our x values, -1, 6, -2, are all unique. So this one is going to be a function. The domain, again, is -2, -1, and 6. The range is -3, 5, and 1. Next, we have mapping. Remember, the first oval or circle or rectangle is going to be your x value or your input. And the second would be your y value. So we'll take a look at this. Our domain here is just our list of x's. So -2, 3, and 4. Our range is 0, -1, -2. And it is a function because I don't see any x values repeated. Next one, here we just have a set of ordered pairs. So again, I'm going to look at my x values. And that's going to be the deciding factor as to whether it's a function. So here again, I have all unique x's, so it will be a function. My domain, again, is just the list of x's. And my range, if you take a look at this, the range had 2 number 9s. So in the range, you do not have to list them twice. You can just list them once. All right, so that was determining a domain and range from sort of a discrete graph, just a bit of points. They weren't connected in any way. Now we have what's called a continuous relation, or perhaps a function, where our dots are now connected. So we're going to take a look at this. When our dots are connected, we want to use inequality symbols. And the way I teach my class for domain, we always want to read it. And you can do this a couple of different ways, but to get the handle on it to begin with, we're going to always read our graph from left to right for the domain, and the range, we're always going to read it from bottom to top. Remember, your domain is going to be x values and your range will be y values. So let's take a look. If we're going to list out the domain, we want to start by reading our graph from left to right. So remember, your domain is your x values. So I'm going to look at my x-axis and go over to the left as far as my graph will go, which is right here. That's as far as my graph will go to the left, and that value is at -4. How far to the right does it go? So if I go all the way over, this point here looks like my rightmost point. It goes over here to 4. So we're starting to build an inequality here. What needs to go in the middle? We need to put x's in the middle because this is the domain. We're talking about x values. And the next thing I want to look at is the graph and what is at these endpoints. So these are closed circles. Closed circles tell me that they're included in my picture. So when we read domain from left to right, we're always going to use less than or less than or equal to symbols. And in this case, because I've got closed circles, we're going to use less than or equal to. Your domain is basically telling you how wide is your graph, how far to the left and to the right does it go. Your range is going to be talking about how tall your graph is. How low did it go? How high did it go? So again, on my y-axis, because range is y, I'm going to go as low as my graph will go. And my graph goes all the way down here to -2. So I'm going to start at the low point again. How high does it go? It goes all the way up here to 2. That's how high it goes. Are we talking x's or y's when we talk about range? We're talking about y's. And again, if we read our graph from bottom to top, we are still going to use less than or less than or equal to symbols. So here we're going to go ahead and do less than or equal to because my graph included those dots. They were closed circles. Is this a function? If I draw any vertical line on there, is it going to pass my vertical line test? Yes, it will. So this is your domain and range. Here's another continuous graph. It's like a U. Now we got to be careful here. I've got a closed circle and an open circle. We're going to start with the domain, and the domain is how wide it goes. So if I were to trace it, I start over here and I go down. I don't care about the going down, but I want to know how wide it is. How far is it from left to right? So if we take a look, it's over the -2 on the x and over the 2 on the right. So those are my endpoints. I'm going to start by drawing out my domain that way. -2 to 2, that's how far it goes. I know I need x in the middle. Now on the left side, we included the dot. It's a closed circle, so I'm going to use that less than or equal to. But on the right side, we had an open circle, so that's just less than. That's my domain, how wide it is. I'm going to erase all my markings on there. And we'll talk about the range. My range, remember, is how tall it is from bottom to top. So when we take a look at the range, it goes all the way, it goes down like this, but it goes up. It goes from here to here. My lowest point on the y-axis is at 0. That's how low it is. And then it goes all the way up here to 4. That's how tall it is. So I'm going to start by writing down 0 and 4. We're using y values here. Now my low point on my graph, I see the line goes through that point. So if I don't have a dot there, but it is on my line, I want to include it. So that's going to be less than or equal to. Now here's the tricky part for this one. What about up here? Because I see both a less than and I see a less than or equal to sign, possibly, because I've got to open and a closed circle. At the top point, are you including 4 anywhere on your graph? The answer to that is yes. Right there, we are including 4 right there. So for the 4 part, I want to have less than or equal to. Is this one a function? Drop a vertical line in there and whoop, there it is. Only one spot, so yes, this is a function. Taking a look at a few others. This one's unique. I don't know if you can see this. I have an arrow on this side, so I'm just going to make that a little bit bigger so it's obvious. Again, my domain is how wide the graph is. So I can tell it starts over here on the x at 0. And it goes, it keeps going. It goes on and on forever in that right direction. So this one's going to be a little bit unique in how we write it. So we are going to start off with 0 as the leftmost spot. And I can see a dark circle here, a closed circle at that spot. So that's that's less than or equal to. We're talking about x's. And I know some people are going to say, shouldn't that be a 1? Shouldn't that be a 1? That's the height on the y-axis. That's not how far to the left it goes on the x-axis. So be careful with that. It goes only over here to 0. It doesn't go past 0 in the left direction. Now, because it goes on and on forever in the right direction, I don't have an end point. I can't put like, 7 or 71 over there. I can't do that. There's no end point there. So we actually just stop writing our inequality, just like that. We'll take a look at the range. The range is similar. So the range, remember, is how low it is. It's this low. It's at 1, less than or equal to y. How high does it go? If you look at that arrow, it's still going up, up, and up, 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 and up. So there's no topmost point to my graph, so we're going to stop right there. Is this a function? Let's draw our vertical line. Yep, it only hit my graph in one spot. We're just also reviewing last class too. All right, we've got this upside down curve here, this N shape. So let's see, it's got arrows going in the downward direction here on both sides of my graph. So let's take a look. How low does it go? Is this the low point? Does it stop right there? No, it keeps going down forever. So we don't have a number here, but we are talking about x's. We can see, oh, I'm sorry, I'm starting to talk about the range already. Let me go back a second. Just kidding. When we're talking about domain, we're talking about how wide it is. So let me go back. How wide is it? Does it stop right here? Is that as wide as it goes? With those arrows, it keeps getting wider and wider and wider forever and ever. So in this graph, because it keeps getting wider in both directions, to the left and to the right, we're going to say our answer is all real numbers. There's no limit to what my x can be. I can pick any x I want, and I'm going to be able to plot it on this graph. Now let's talk about the range. Our range, remember, is bottom to top. We want to read it bottom to top. The bottommost point, does it stop right here at -1? No, with those arrows it keeps going down forever. So we start off with not being able to write a number to begin with, but we are talking about the y's. And there is a topmost point. It goes all the way up to here. That's the peak, and that's it too. And again, just like our last graph, because I don't have an open circle there, where it is included in my graph, so I'm going to use less than or equal to. Then I can go ahead and erase this marker. I put that in there just because we didn't have a bottommost point, but we did have a topmost point. And when I graph my line, yep, this one is a function. So what we've done so far is given a domain and range. So we've already done this, all of these examples. This is what we came up with for our domain and range. The next part of our lesson is just translating this into what's called set builder notation. It looks a little scary, a little bit fancy, but really all we're doing is kind of breaking up our inequality. We start off with the curvy bracket, do any sort of squiggle you can. And for the domain, we're talking about x's. So we just write x and then a vertical line. After that vertical line comes the inequality, and we already wrote it down. We said -4 less than or equal to x less than or equal to 4. End it with a curvy bracket, and you're done. Range, same thing. Curvy bracket, y, draw the vertical line, and then we give the specifics. -2 less than or equal to y, less than or equal to 2. Next one, same thing. Curvy bracket, and look, mine was pretty messy, that's okay. X such that, and then we go ahead and write in the inequality. Our y, same thing, y. Draw that vertical line and just go ahead and drop in what you claimed was your range. Here's another example. And again, we just talked about these. Let's take a look at letter D. It says all real numbers. How am I going to drop that in? We start off with a squiggle. We're talking about the x's, so we just do this. We just write x after that vertical line. And that represents all real numbers. You can do that for the x, you can also do that for the y value.